This is the final video in the PCA music analysis series. First two videos showed you how to do PCA generally, and then how to do PCA on recordings, and finally we're going to do some PCA on MIDIs. We're going to rely heavily on the time-blocked MIDI analysis from the first part of the Homework 3C video. So if you haven't watched that, go ahead and watch that now. Also have a look at the PCA video, the first one in this particular series. To get started, we need our usual libraries. We need the Tidyverse library. We need Tabber. We need, and I think that's actually it. Okay. Now, once we've got these in hand, I'm just going to repeat the analysis that we did, or rather to build up all the data from the Homework 3B and 3C videos. So I expect this is the sort of thing that once you kind of see it, you kind of know what I got to do. If not, have a look at those videos. This takes a little while to run, but I'm going to suck in a whole bunch of MIDI files and stack them into a table called Songs Notes. That Songs Notes table will have all the note events, all the frequencies, and the start and end times of each note, as well as the lengths of the songs. This takes a few moments to run, but once it's done, we're in good shape. Okay, so let's take a look at those Songs Notes. There's a bunch of different songs here. Which one is which? Well, there's a name column. There's the name column. We've got the notes, the frequencies, their start and end times, the total time, and furthermore, we've blocked up into time blocks as per the previous videos. Okay, it's a whole bunch of wrangling, but it's basically just exactly the same as what was done before. All right, what we want to do now is we want to group up these blocks and then collect up the notes that are present there and look at the note start times that are present and use those as to build a table of note blocks versus note start times within the blocks, offsets from the beginning of the first note. In music theory, these are called inter-onset intervals, or IOIs. And they can be used to do a lot of neat stuff. Okay, so let's start doing this grouping. First of all, we need to know where the notes that the first note in each time block is going to be. Way to get that is to do a little group by. Group by. And sort by these guys. And we want to add a column to each of these note start times. So this is this note starts guy. Let's take a look at it. Looks pretty much like what we had before, but now all that's happened is we've grouped them by name and time block, which doesn't show up in the view, and we've sorted them based on time. Okay, and we've sorted and grouped them. Next step is to figure out which position each of these notes are within the time block. So for instance, this is the first note in this first time block, this is the second, and so on. But you maybe at the beginning of the next time block, you want to count them up as well. Okay, so let's do that. So let's add this num within block column, and this is basically just the row number. You might say, wait, why? That's because of the way we've grouped. We've grouped by name and by time block. So now row number is going to count up within each of these groups. Okay. We also need to know what the time offsets are. And I'm just going to alter the time altogether so that the time is just the time within block. Okay? And now there's a lot of columns going on. Let's prune down the columns. So what columns do we need? We want the name, the time block, and the num within block. Okay, now, if we take a look at what this looks like, let's see where we're at here. Note, oops. In fact, no need to put it into a view. You can see that we've got the name, the time block, and the number within block. Each note is a separate row. We really want to pivot this a bit wider so that we've gotten each block is a row and each column is a note time within block. Okay, so this is a pivot wider. Normally I use pivot widers just to make things a little easier to read, but it actually is pretty handy in this case from a data standpoint. So not just for human consumption. So our names we're going to pull from the num within block, and the values from time. We go ahead and do that. It's actually handy to get rid of the grouping at that point, because now we've pretty much organized our data the way we want them. Now we've got the name, the corresponding time block, and the notes within block. You can see Bach is pretty regular, pretty stable. And that is indeed because Bach is Bach, after all. Okay, let's not take all of these columns, because unfortunately, there's lots of NAs present in this column, or in this data. You can't see them in the Bach data per se, but they're definitely present. You can see there's some NAs. There we go. And principal components analysis does not like NAs. Multiple dimension scaling does, but it's a fancier tool. Additionally, principal components analysis does not like a column of zeros. So if you go ahead and examine what these note starts look like, it kind of is just easier to pull off the first 5 of them. Most of these songs, actually all of the songs I'm looking at right now, have at least 4 notes per block. So let's pick out the name, and let's get columns 2 through columns 5. Kind of neat. You can use the colon to say from to end, and you can do something like this. Pick out just the Bach columns and have a look at them. There they are. Pretty rigid. Now, this is not the only possibility. Here's an improvisational piece. You can see that they vary quite a bit. Okay, well, now we're ready to run PCA on all of this. PCA is a base R function, so it doesn't know about tidyverse groups. So we need to do a filter for it. PCA also does not like the name column, so let's get rid of it. But at that point, we're ready to roll. Let's take a look at it. If we want to visualize it, we need to coerce this into a tibble so that we can use the tidyverse plotting. And I'm going to use geom count because this mitigates some overplotting. And in fact, you can see, hey, there's a big pile of notes that are note blocks that are all very rigidly structured, and then a few other outliers. So Bach is pretty regular. If instead of Bach we looked at one of the other pieces, there's a bit more variability. You can do this kind of analysis, this PCA analysis, with various other kinds of properties, not just IOIs, timing, but other things as well. This IOI analysis, however, is a pretty good way to get a nice picture of what rhythm looks like. It's a general tactic to use PCA on your tabular numerical data, and the idea of this pivoting to get some numerical data formatted and grouped into a nice table is a pretty common strategy. Hope this turns out to be useful to you, and I hope you enjoyed it.